Hello, ladies and gentlemen. Let us meet in one of our important sections of our electrochemistry, in which we are going to look on the examination type questions from the previous years. These particular questions have actually changed the lives of other students who are like you. We have become doctors, some have become engineers, and some have become lawyers, and any other careers which you can think of in the world. They have been changed because of some of these particular examination questions. So you can also change your life when you are going to take these examination type questions seriously. So I really beg your attention in this particular section of our electrochemistry. So we are going to have the first question, which we are going to say is 1.1. The question says, rusting is an unwanted redox reaction. Underline redox reaction. Iron rusts when exposed to oxygen and moisture. The unbalanced ionic equation for one reaction that occurs during rusting is represented below. So we have this particular reaction, our iron solid plus our oxygen gas plus our water liquid will give us iron 2 plus in aqueous form plus our hydroxyl ions also in aqueous form. Remember, we have been told that this particular reaction is a redox reaction which is happening in the rusting of iron. And remember, we have been told that the conditions which are favorable for the rusting of iron is the presence of oxygen as well as the presence of moisture, that is water there which we have, right? And we have been told that this particular reaction is a redox reaction, although it is not balanced, which means to say that we have both oxidation and reduction reactions which are taking place in this particular reaction. So now let us break this particular reaction, and we have been told that it is unbalanced, right? So we have our iron solid there, and we are having our iron 2 plus there, which means we are going to have a reaction in which we are having our iron solid being changed to iron 2 plus. So let us just write that one down. We have our iron solid being converted to iron 2 plus aqueous ion. As we can see, this one is not balanced. We have zero charges there, and we are having a charge of +2 this side. So we are also supposed to have to balance the +2, that is by adding 2 electrons on this side. So as we can see, our iron has been changed to iron 2 plus by losing electrons. And remember, we defined oxidation as the loss of electrons. So this one is an oxidation reaction. So what are we saying? Our iron oxidation state, because this one is an atom, so it has an oxidation state of 0. And now we are having an oxidation state on iron 2 plus, which is +2, which means we have an increase in oxidation number from 0 plus 2, which is an oxidation reaction. And now we can actually break this other one now, our oxygen plus our water. That is, if we go to our standard reduction potentials, we are going to see to it that we have our oxygen gas plus our water is being converted to hydroxyl ions, right? As we can see from this particular reaction, we have just taken it straight from our equation. But if we look from our standard reduction potentials, we have that this reaction, there is +2 there is +4 electrons, and then we are also having 4 hydroxyl ions. We have just taken this one straight from our standard reduction potentials, right? As we can see, we are adding electrons there. Remember, we actually defined reduction as the addition of electrons. Therefore, this one is a reduction reaction. And what is our question saying? The first question says, on 1.11, write down the oxidation half reaction. So our oxidation half reaction is iron solid being converted to iron 2 plus 2 electrons. Then our question 1.12, write down the name of the substance that is reduced. In this case, we have said that we are adding electrons there. So consequently, this one is a reduction reaction. And now we want to see what is being reduced. What is being reduced is our oxygen gas there. So our question 1.12, which is saying write down the name of the substance that is reduced, oxygen gas is the one which is being reduced. Then we have question 1.13, perform a calculation to verify that this reaction is spontaneous. Remember, when we discuss a spontaneous reaction, we say that we can actually obtain our spontaneous reaction when our electrode potential, our overall electrode potential of our cell is positive. Then we are saying that our reaction is spontaneous. So let us see our chemical reaction which we have. Let us have from our standard reduction potentials, our iron solid being converted to iron 2 plus 2 electrons. This one is an oxidation reaction. If we are going to actually see from our reduction potentials, the reduction, the forward reaction is an electrode potential of minus 0.44, but we want the reduction of iron solid to iron 2 plus. Therefore, we see to that we are going to reverse our electrode potential to plus 0.44 volts, right? Then now that one for oxygen, we are going to take it as it is. We are going to have our oxygen gas plus our 2 water plus our 4 electrons. We are forming our 4 hydroxyl ion. The electrode potential for this particular reaction is plus 0.40, right? So if we are going to add these particular electrode potentials, we can actually find the electrode potential of our cell. We can actually obtain our electrode potential of our cell. So our electrode potential of our cell is equal to plus 0.44 volts plus 0.40 volts, which gives us plus 0.84. So this one in itself tells us this particular reaction is spontaneous. Why? Because it is positive. Or we can use that other formula in which we say that the electrode potential of our cell is equal to the electrode potential of our reduction reaction minus the electrode potential of our oxidation reaction, right? And remember, when we are using that particular reaction, there is no need for you to actually reverse. You would take your electrode potential